In this video, I'm going to talk about what are the differences between a microprocessor and a microcontroller. I'm going to be talking about the differences from the perspective of designing a software system. So let's get started. Welcome back, everyone. So in this video, let's talk about some of the key differences between a microprocessor and a microcontroller when it comes to designing an embedded software application. So before we get started with this video, make sure that you've checked out my previous video on the fundamentals of real-time embedded systems. I'll put a link to that in the top right-hand corner over here, so be sure to check that out. So here we have a BeagleBone Black. Now this has a ARM Cortex-A8 processor, so this has a microprocessor. Whereas this board over here, this is the red board from SparkFun. This has an Atmel microcontroller chip instead of a microprocessor. So the very basic difference between microprocessor versus a microcontroller is, from a software perspective, a microprocessor is going to be running an operating system. And a microcontroller chip, this usually will be what we call bare metal or bare bones, and it doesn't have a sophisticated operating system compared to what's running on the microprocessor. So for example, on the BeagleBone Black, the operating system that's running on here, this is the it's going to be a version of Linux. So it's, for my case, it's running Ubuntu, and over here, this is running a version of very bare metal software interface that is specific to this microcontroller only. And yeah, so it's not any kind of an operating system. And the main difference here between the two development platforms is going to be that on a microprocessor, if you're running an operating system such as Linux, you have the capability to run multiple processes, multiple threads, whereas on a microcontroller chip, you're going to be single-threaded. So there's nothing that you can run on this microcontroller other than a single thread at a time. So let's start jotting down some of these key differences now. Okay, so here for the microprocessor, I'm going to put this aside in the microcontroller. For microprocessor, we're going to say that you can have multi-threaded applications. And for microcontroller, you can only be single-threaded. So this is a very basic difference between the two different types of development platforms that you can have. But another key difference that really drives your design decisions when you're making an embedded application is what kind of interfaces are you going to be using in your embedded application. So let's take a look over here on our microprocessor platform, BeagleBone Black. What this platform offers you is an Ethernet interface, and also it has a micro SD card that's on board, and you have onboard USB, which you can use for using Wi-Fi adapters on there. And if you have the Raspberry Pi 3, then you actually have onboard Wi-Fi and Bluetooth. So all those different complex interfaces are available for you on a microprocessor development platform. Now, if you compare that to the microcontroller platform, you only have access to the basic interfaces such as I2C, SPI, UART serial, and possibly USB as well. But you're not going to have access to Ethernet or a flash file system or a flash file storage interface that's on chip for you. So if your application is going to be utilizing complex interfaces such as Ethernet or storing data on a flash file system using a micro SD card interface that's on chip and it comes available with a file system ready to go, you're going to be much better off using a microprocessor platform in that kind of a situation versus using a microcontroller. Whereas if your application is very simple, and let's say it only has one or two sensors that use UART or I2C or SPI, and all they have to do is just read the data in and push the data back out over some kind of a serial port, and the application that you're writing is single-threaded, then you could get by with a microcontroller. However, if there is some kind of a need for you to have multiple threads, such as, one thread is reading data from a sensor at a particular rate, let's say 10 hertz. And at the same time, you need to be storing data to the disk but there's no specific deadline for the storing. So what you can do in that case is have one thread that's running at 10 hertz sampling the data, and it passes data to another thread which is going to store the data slowly in the background. So that's a multi-threaded application situation. So again, in that kind of a situation, you'd want to use a microprocessor platform. So let's jot down a couple of those points as well. So another reason why you may want to use a microprocessor platform is if you have complex interfaces. Those would be, things like Ethernet, Wi-Fi, Bluetooth, or you have some kind of a FFS flash file system. So for a microprocessor, a lot of these interfaces, they come available with drivers for these platforms, and that makes your development just so much more easier. Whereas on a microcontroller, you really only have access to some basic interfaces. So those would be like, SPI, I2C, or UART, which is serial. So you definitely want to take into account what type of interfaces do you have in your embedded application when just trying to decide if you should go with a microcontroller versus a microprocessor. Now, another key difference that I mentioned briefly was this idea of having some kind of a rate-driven architecture in your software, where you have one single thread that's going to be using, it's going to be running at a particular rate collecting data, and then you may need to have an additional thread that's going to be running in the background, storing the data or streaming the data online. So in this case, you do need to have multiple threads. So it would fall under this multi-threaded category, but another thing to consider is if you have some kind of a rate-driven architecture that needs to also do some buffering in the background. And over here, you want to make sure that you have a single-threaded application. So if you are reading data at a particular rate and you are going to be storing that to file or streaming it over the web, then you have enough downtime to do all of those background things in your time slice or in your rate group that you're running. So you want to make sure that your single thread can handle all of your rates. It can handle all of the background file storage and data streaming online. So this is stream data. So all of this has to fit into that single thread. So you want to make sure you can do that. And these are the three main things that you want to keep track of and analyze before you make a decision about should I go with a microprocessor or should I go with a microcontroller for my embedded application. So that's about it for this video, and hope you guys found it useful. If you enjoyed it, learned something new, make sure to give it a thumbs up and subscribe if you want to see more videos like this in the future. Also, check out our website, arembedded.com, where we offer a free course on how you can get started with development on an embedded Linux platform. Also, you can check us out on Facebook, where we post all of our tutorials online, and it's a great way to keep up with our content as well. So thanks again for watching, and I'll see you guys next time.